Okay, class, this is going to be another way to do number 3, except using not using the projection formula, but just setting up an equation with dot products. So we know that BE is going to be perpendicular to AP. The problem is we just don't know where point P is, but we do know that it's on this line, on the line that that goes through B and E. But we can write down, we know how to write down the equation of lines. If we have 2 points, we can use the vector form. So BE, the vector, is already right here, and so you just need a point. Well, we have a point B. Oops. We have a point B, so so I know x bar, or the x vector, is going to be 2, 0, 0 plus t times the minus 1, 1, 2. So for any value t, or for all values t, it'll run through all the values of the points on the line BE. When t is 0, I just get B. When t is 1, I get E. So the value we get out of for t that we're going to solve for better be between 0 and 1 for this to make sense. Well, if we're confident that these are acute angles here and here, because this needs to be perpendicular. So what we know is that so what I'm going to do is set up this, is to look at AP, like look at that vector, and dot it with BE. And then solve for t to know when those are perpendicular. So P has to be on this line. So P is one of these points here. We don't know which value of t will get us those, but it has to lie on that point. And P is a vector. The vector AP would be whatever point on this line it is, 2, 0, 0 plus t minus 1, 1, 2. We don't know exactly where it is, but it has to lie on this line, minus the origin. So AP we could think of as that, which is just that line, because we have a vector in standard position, because A is the origin, 0, 0, 0, right there. So AP dot BE needs to be 0. So 2, 0, 0 plus t minus 1, 1, 2. That dot minus 1, 1, 2 has to be 0. So this is BE, this is AP, and now we have an equation with just one unknown, which is t, and this will tell us at what t value those two things are perpendicular, AP and BE. So we can use what we know about the properties of dot products. So we're going to distribute this out here, so we can get 2, 0, 0 dotted with minus 1, 1, 2 plus t minus 1, 1, 2 dotted with itself a minus 1, 1, 2 equals 0. And here we do the dot product, we end up with a minus 2 plus 0, 0. And here we end up with 1 plus 1 plus 4, which is 6. So 6 times t equals 0, and then we solve for t, and we get t equals 1/3. And so at the value of t equals 1/3, we should get that's the point. So we can go back to the point of this line. These are all of the points on BE, the line BE. So at t equals 1/3, then it'll tell us what P is. So 2, 0, 0 plus 1/3 minus 1, 1, 2. And what do you end up with? Exactly what we found the other way. 2, 0, 0 minus 1/3 plus 1/3 plus 2/3, which is 5/3, 1/3, and 2/3. Okay, so that's the point. The trick here now was to recognize that P is on this line, and we can write down the equation of that line here in green, boxed in green, and that we can write down the vector AP, even though we don't know what P is exactly. We know it has to be one of the points on that line, and then we use the power of equations to solve for what t equals. So that is another way to solve that problem.